think we'll start. Thank you very much for attending my talk. I think it's right now the best room to be in because of the heat. And yeah, my name is Max. I'm an Apache Flink and Apache Beam committer. And I'd like to tell you about Flink and Beam today. And more specifically, actually, I like to talk about the Flink Runner, which enables you to run your Beam programs on top of Apache Flink. So you should expect to learn about, of course, Apache Beam. We've already received a lot of input from Kenneth, so I try not to repeat anything. And then you will learn, of course, about the Flink Runner, its state, and the roadmap. And I will also do a little demo to showcase the runner, to show you that you get additional benefits, you get the benefits of Beam, and you get the additional benefits of the Apache Flink runtime. So, I don't know if anyone attended my last year's talk at Flink Forward, but if you did, you may realize it has a totally different title. Last year I talked about the Google Cloud Dataflow and its runner, and this year it's everybody talks about Beam. So you might ask, what happened? Yet another system. Ken has already pointed this out, but just to show some nice graphics from Google here. So the SDK was released in December 2014. And it is now, as of February 2016, it's basically, it has turned into Apache Beam. It has been forked, more specifically. And what is the underlying idea of Beam? So we have all these big data publications at Google, starting with MapReduce and then with a bunch of other systems, most prominently, at least for us, as the Flink community, MillWheel and Flume. And we have this awesome service, Google Cloud Dataflow. But on the other hand, we have all these open source projects which were inspired by the papers, but also have, of course, their own way of doing things. And the idea is to have a common unified API to program in and to sort of access all these systems, whether it's on the Google Cloud or in the open source. And that is Apache Beam. So yeah, this is a little bit repeating what Kenneth already said. So the Dataflow SDK is really phasing out. It's only, I mean, it's not clear when exactly, but slowly it will be deprecated, and Beam will become the new thread where all the development is focused in the open source. And yeah, we are now at release 0.2 in the incubating project, and yeah, it's developed very rapidly, so expect many more versions this year. I want to talk very briefly about the Dataflow Beam model, because it's always mentioned and it seems a bit vague for some people. So the Dataflow model, or nowadays the Beam model, is basically starting with MapReduce and then most prominently Flume and MillWheel is like a compilation of all the knowledge that has been published. In Flume, this is mainly the API with the P collections that has made it into Beam. In MillWheel, it's the watermarks exactly once, the windowing and triggering that is part of Beam. And all this was sort of compiled in a paper in September 2015 and published at WheelDB. And yeah, this has been also a huge impact for Apache Flink. So you can see that only 2 months later, Apache Flink 0.10 actually featured event time. And that is also because we were inspired by all these ideas. So a lot of things were already in Flink before, like exactly once, We had already triggering and windowing, but the event time came November 2015. But Flink is not a copy, of course. It has its completely own API, dataset, data stream API for batch and streaming. And it has, of course, a complete open source runtime and many connectors and libraries, which are not yet present in Beam. But we're getting there. So what are Beam runners? Because I'm talking about the Beam Flink Runner today. Just to repeat this a bit, but a runner is basically the piece that sits in Beam, which manages the translation from the Beam API to the backend API. And not only does it do the translation, it may also do some sit in between sort of the Beam API and the Flink runner to the Flink backend to do some runtime execution of the code. And we have currently 3 runners available. That is, of course, the Google Cloud Dataflow runner, which was the first runner, and then the Apache Flink and Apache Spark runner. Kenneth already mentioned there's a pull request for the gear pump runner, which will be in soon too, and there are plans for an Apache Apex runner. The runner, of course, also, because it is part of Beam now, shares the same release cycle. So we have a stable runner, as 0.2, powered by Flink 103, and the snapshot version 1.3, powered by Flink 112. And at this point of time, because we're still in the 0x phase, of course, many changes come in. And actually, I was pushing some changes before I did this talk. I was opening pull requests because I realized some issues. I think this is normal because it's still a young project. If you try it out, give us feedback on the mailing list and or open Jira issues. I'm sure we can sort out the issue pretty fast. To understand how the Flink runner reached its current state, I want to give you a brief history of the Flink runner. So I divide this into 2 sections, the sort of data artisans era and the Apache area. So in the beginning, people including me at Data Artisans, were, after the Google Cloud SDK was released, were investigating how to create a runner. So we did the initial commit in January 2015, and pretty much had a sort of first version running in March. But that was really a sort of toy runner, I would say, because it supported batch, but without windowing. And so it was more like a, I don't know, MapReduce Hadoop version of the runner, which didn't really support the Dataflow model. Then in December, we implemented the first streaming support with watermarks and windows. So we were getting closer to a real proper support of the Dataflow model. Then we contributed the runner, which was sitting in a separate repository, to the Beam repository in March this year, and actually did a lot of work since then. I don't know if Alyosha is here, but yeah, thank you. He did great work there. So before the sources were sort of limited to parallelism 1 and were not checkpointed, and we fixed that. Enabled them to execute in parallel and support the interface properly. Also, we added batch support, batch support with windowing and side inputs, and integrated with Beam's runnable on service tests for batch at first. So these runnable on service tests are basically a series of integration tests that make sure that the runner is actually executing the Beam program correctly, and there are various checks to ensure that the results are correct. And then we also had in August a version for side inputs in streaming, and also there the testing integration. So as I already mentioned, the runner has 2 execution modes. This is just, I guess, because of the nature of the Flink runtime, which always had these 2 API. Well, started off with batch API, but then also had a streaming API. Semantically, also, I think it's the same for the Google Cloud Dataflow Runner. It's the execution, I mean, the result should be the same, but you just have you have some limitations with the batch runner because you can only execute bounded sources. But you get, we will see that later, you get some additional benefits when you use the Flink Runner, like managed memory, where you can perform sorting and joining in Flink's managed memory, so that gives you a more robust execution. And on the streaming side, we use the DataStream API, which support both bounded and unbounded sources, and it has the support for the full Dataflow model, which includes watermarks, which you need when you have an unbounded stream, and it also integrates very nicely with Flink's checkpointing algorithm. And yeah, which one should you pick? Don't worry, actually the Flink Runner will just decide. So if it finds an unbounded source, it will use the streaming mode. So what are the strengths of the runner? These are just a few points I wanted to highlight. So we have a backend which can do batch and streaming, well, depending on your use case. And we actually don't try to re-implement the Dataflow model in Flink for our runner, but we only try to embed the Beam logic where possible. So we don't use our own windowing and triggering, but we use Beam's classes to achieve that, and sort of just wrap them to execute them in the Flink streaming runtime. Then we fully integrate with the source API, which enables you to use any custom sources, create your own custom sources, or use sources in Beam like Kafka or PubSub or BigQuery if you want to use the Google services. Same goes for state internals and checkpointing, where we ensure that the state you keep in operators is properly checkpointed by Flink to ensure proper fault tolerance. And yeah, there are many small things that I think make the runner powerful. So for instance, Beam has this notion of composite and primitive transforms, and we try whenever possible to implement the primitive transform. So if, for example, if you have a combine, which is the reduce in the classical reduce in Beam, then you might have a combine for group values or to combine values globally, but basically these can be broken down to more primitive transforms, like combine per key. So that's where we try to avoid duplicate work and leave it up to the Beam framework. Yeah, and I mentioned the runnable and service test. I think these are the strengths. So next, I want to show you a little bit of proof for all this, because this sounded all very theoretical up to this point. So I'm using the classification that also Google uses, and the Beam community decided would be a good way to classify capabilities of runners. So this is the typical what, where, when, how, as we saw in Kenneth's talk. Just to get you up to speed again, if you already forgot what it meant. So what is basically the transformations you apply on your data. The where is in your data, how do you establish order? Are you using processing time or event time? Then you have to execute at some point to get results. This is the when. And the how is like what you do later on when you receive new elements. What you do with with your state, how do you apply updates when you receive additional information. And to show you the current matrix, this is how it looks for the what section. I think we can say that in terms of this capability matrix, we are pretty much on par now with the Google Cloud Dataflow Runner, which admittedly wasn't the case always, but since a week, I think we are there, and especially because we have now side inputs and streaming, which were missing for some time, and which were a bit challenging to implement. Yeah, but other than that, keyed state, for instance, we can implement if the Beam model supports it, because Flink supports keyed state. Then we move on to the where section. Pretty much here we support also all windowing mechanisms because we use the Beam windowing logic. Then we go on to the when section. So this is basically the triggering of the windows. And here also I think we're on par with the Google Cloud Dataflow Runner, yeah, in terms of capabilities. And just for completeness, the how, similar situation here. There are these two modes right now, discarding or accumulating. So whether you keep the state after you fire a window or you accumulate, so you keep the state around to refine data when refine your state when new data comes in or fire again. Okay, so we're good, right? Looks like we have done all the work, and we have currently maybe the most advanced open source runner. Does it mean the runner is perfect? Of course not. I don't want to be that bold. So there is a roadmap for the Flink Runner. First of all, I mean, this doesn't really have an order actually. There are size restrictions still in streaming, because the way we implemented it, this will go away when Flink has native support for side inputs, I suppose. And there are many API changes, like the pipeline result, which gives you control over your job once you run your pipeline, to cancel it or get some intermediate results. And there is dynamic scaling, which we very actively work in the Flink community on, and it will also make its way into Beam. I think we have a talk later on by Malo, which will give us more information. And then, of course, Flink has many libraries like Jellies, CP, the machine learning library, and of course we would also like to bring these to Beam or implement new libraries in Beam, but this will happen over time. Same goes for the connectors, which they're currently, I think, more open source connectors in Flink. So you can actually use these, but I mean, these native connectors with the Beam runner, but of course you lose the portability then if you want to use another runner like Spark or the Google Cloud runner. Then of course we have some benchmarking performance testing to do and many bug fixes. So before I give you a little demo of the runner, I want to highlight some of the features of the Flink runtime, and in particular, checkpointing and save points will be interesting for us during the demo, because I will show you that this also works for Beam programs. And same goes for the state backends, where basically you have an option, if you have really large state, to store that outside the heap, the JVM heap, using, for example, RocksDB. And batch also has some advantages when you use Flink, like pipeline execution or managed memory. And we have also, whether it's streaming or batch, high availability support, so when the master fails. And I mentioned Flink's native sources and sinks. Okay, so now let's move on to the demo. I wanted to show you how you would start developing a simple Beam program with the Flink Runner, how you can use the web interface to monitor it, and how you actually, when you have a failing job, failing Beam program, for whatever reason, you can restore your state and your execution from the latest checkpoint that Flink creates on regular intervals. And also, it is possible to create a save point of Beam jobs, bring down the whole cluster, and update your Beam version, and then restart the cluster and the job execution again. So let me change the Beamer now. I hope this doesn't screw up the recording. Okay. So I created this very simple Maven project using the quick start on the Apache Flink homepage, and all I did was go into this quite verbose XML file of Maven and add a dependency on the Flink Runner. So this artifact is called Beam Runners Flink, and I use the latest snapshot version. Then I create a really simple Beam job, which doesn't live up to Beam's capabilities, but it should be simple so that you can understand it actually. So I'm instantiating the pipeline options from the arguments, and in case I want to parameterize my Beam job, and then I simply have to set the runner on the options. I can then go ahead and create a pipeline, and for this test, I created a really simple source which emits integers and lets me see that it always increments the integers regularly, and lets me see that the order which I'm receiving these is actually according to event time. We will see later on when we execute the program. So what am I doing with these numbers? So I create a window, which is a fixed window of 3 seconds, or tumbling window in Flink, and I trigger after the watermark is past the end of the window, and I don't allow lateness for this example, and I discard any fired panes. Then I'm simply using combine globally to print out these integers which are part of a window. And yes, I think I could show you more, but let's just execute this program to see what it does. So you can see some log output from the Flink cluster, the local cluster, and you can see that it emits a window every 3 seconds, and the counts are always increasing. So not too interesting, but let's make it a little bit more interesting. So I have created a very similar class here with a few additions, which also has a Flink Runner, but it has some custom options, my options, which are at the top. And there I can set a parameter to fail after some timeout in seconds. So I'm using this timeout, which I'm reading here, to pass it to the preprocessor. So because apparently my preprocessor is sometimes failing, especially every 10 seconds. And I'm also exposing the current count to make that visible on the web interface. And but the rest is unchanged. And I enabled checkpointing in a 1 second interval. So when I now execute this, we expect to expect the same output, but after 10 seconds, we expect the pipeline to fail because my preprocessor makes a null, probably a null check, and it doesn't do a null check, so it fails. And you can see that it starts off with an offset here, and this should be exactly 1 higher than the last one, and that is true. So Flink actually checkpointed the state, thank you, not only of the source, but also of the window operator, which always buffers 3 elements because we emit new integer every second and have a 3-second window. So it also manages to correctly restore the state of the window, because the failure can also happen when the window is not yet completed. Okay, so this seems to work, but let's see how this works in a real cluster. Whoops. So so I started a cluster actually. Where is it? Here with the Flink UI, yeah. And I have already executed some jobs. You can see the history here, but currently nothing is running. So let's run the job. So first I have to compile it. So here it is. Then I'm submitting it to the cluster with this parameter to fail after 10 seconds. So it is running. And we can see here there's a new running job. You see it? Yeah. And if we access the job, we can see the topology here, which is not looking so nice. Probably we could improve that. But if we go to accumulators now, we can see the last value we've observed. And we can see that in regular intervals, we are switching to failing and then to running again. And we're starting from the last offset again, and we store all the correct state of all the operators. So let me now go ahead and fix this issue. But I don't want to destroy our current count. So I'm going to go ahead and get the job ID of the job, which I can also check out here in the web interface. And then I will create a save point of the job. So I do this just by using Flink save point and then the job ID. So we have now created a save point, which should be around 120 or so. Let's see. So I can go now ahead and cancel my job. So we can see under running jobs, nothing is running anymore. And now I will use the save point address, which can be, this time we are saving the save point in the job manager, but it can also be on the file system. It's configurable, but this is the default. And then we will run this again, but we will remove the failing parameter and recover from whoops, this is fault. Recover from the save point we just created. So there we go. It runs on our running jobs, and if we look at the accumulators, we see it clearly didn't start from 0, and it keeps incrementing, so the job is actually running. And this pretty much concludes my demo. I have 5 minutes, so more time for questions. Thank you very much. Do you have any questions? Oh yeah, there.
Is there a Scala API?
You weren't here at the last talk because this question was already asked. There's not yet. There's an unofficial Scala API made by Spotify, which is available on GitHub called Xio. But it's, I think, based on the Dataflow SDK still, so it needs to be updated. There are definitely, I think, plans at some point to create Scala API or some nice Scala classes to interact with Beam pipelines. Yes, shouldn't be too hard.
Cool.
There was another question over there. No, this is okay. All right. If there are no more questions, then thank you for your attention, and I see you around, and please ask me questions when we meet. Thank you.